Okay, this little bonus section consists of two parts. It consists of a miniature golfing part. So you can actually use this when you're playing miniature golfing someday. And just another little tool that we get from Algebra 1 that I just want to remind you of from Algebra 1 so that you can use it the rest of the year. Okay, first thing is miniature golfing. The first thing you have to understand about miniature golfing is that when I have like a wall like this, and a ball comes in and hits the wall and then bounces off, that this angle here is the same as this angle right there. The angle of incidence is equal to the angle of reflection. And that's a concept that you'll probably learn if you are taking physics this year. Okay, so the way we approach these problems is what we want to do is we want to, if this is the hole that we're trying to get it into, and this is the ball, we want to reflect the hole, we want to work backwards, reflect the hole over the walls we want to bounce the ball off of. So, and we're going to do it in reverse order. So it looks like if I try to just shoot for straight in, it's not going to work. You can all see that this is going to hit this wall and it's just going to cause all sorts of problems. But it looks like if I bounce it off of perhaps this wall and then this wall and this wall, I can make it go in. So the question is, where do I aim for on that first wall? So what I'm going to do is I'm going to go ahead and I can see that I want to reflect it over this wall and then this wall. So I'm going to work backwards and I'm going to take the hole and I'm going to reflect it over that last wall that I wanted to bounce it off of. So it's going to look like it's right there. Okay, and then now I have to reflect it over this wall right here. And I'm reflecting this hole backwards. So I'm just kind of eyeballing it right now and it's going to be right there. And so what I'm going to do is instead of aiming for the hole here, I'm going to aim for this hole that we've reflected over. And so I'm going to shoot it for that hole right here. And guess what? It's going to hit this part of the wall right here. And then it's going to go towards this hole right here. But it's going to hit at this wall right here. And we'll go into the hole. Now there's some geometry involved here that we'll talk about later on in the year. But basically, this angle of incidence and this angle right here, they're going to be congruent to each other. This one right here and this one right here, they're going to be congruent to each other. Okay. This next one here looks like I need to bounce it off of, well, let's try this last one here. I can try shooting it off of just this top wall and bounce it, but it looks like it's not going to work. It's going to hit something there. So let's not try that. Looks like I might have to go and hit it off of, I could try, aiming for this and then something like that and like that. That does not look like it's going to work at all. So it looks like I might actually have to do 3 walls on this one. I might have to actually aim for this wall, and then this wall right here. So I'm going to do this one first, this green one, and then it's going to end up being this second one here, and then it's going to be this third wall right here. Okay, so let's go ahead and work in reverse. So the hole reflects over the last wall that it's going to bounce in before the ball goes in. It's going to go here. It's reflecting over that wall. And now I'm going to reflect it over the orange wall, which is this one. And so the ball is going to end up like up there. And now this one's going to reflect over the green. It's going to go way over to the left. Here's my green. It's going to reflect again. This is not exact. I want you to try to measure it out. It's going to be like somewhere about there. And so I'm going to aim the ball, and hopefully you'll have a straight edge. toward this part of the wall. It's going to hit that part of the wall. It's going to bounce and then head towards the orange. Oh, and I can see already that I messed up. Okay, can you see that it's not going to work? It's going to hit that part of the wall there, so this is not going to work. So it looks like I might even have to go for, if possible, it might look like I'm going to have to go for 4 walls there. Okay, let's talk though. I know I didn't quite get the chance to finish that one, but let's talk about applying some algebra to these type of problems. So we have the same situation here, except now I'm going to give some numbers to some of these locations. So what you have to imagine here is the x-axis, here is the y-axis. Okay, so this point where the ball is 6-2. The hole is at 2-4, and I want to try to bounce it in off of this wall. I want to find this point though that I'm going to bounce it off of. And I know that the wall, the location of the wall, is a horizontal line with the equation y equals 13, and the wall down here is a vertical line with the equation x equals 7. And so I'm just going to do the same thing we just did in the previous problems up above. And I'm going to take the hole and I'm going to reflect it over the one single wall that we wanted to hit, which was reflected over to here. And I know I can find this point of reflection simply because I know that the line that it reflects over is the line y equals 13. So I know that the x value is going to be 2, so it's going to be 2, and then I believe it's 22 to get to there. And then I need to find this point right here, this W. It is not necessarily the midpoint, although it does look like it is, and I don't think it is. But what I need to do here is I need to find the equation of this line. And that should be pretty easy, because I know I have 2 points. I have this point down here, the ball, and I have this h prime here. And I can find the slope. So let's find the slope. So the slope is going to be 22 minus 2 divided by 2 minus 6, or negative 5. That's my slope. Okay, which makes sense. It's a negative slope. It's a pretty steep negative slope. And my equation now is going to be y minus 2 equals negative 5 times x minus 6. And then I can, I know the y value already. I know that this point has to have a y value. It's going to be x comma 13. And to find the x, I just got to plug in the y. So the y is going to be 13 here. My x value, I believe, ends up being some fraction. It's like 19/5. And so the coordinates of the w there end up being 19/5. If I'm doing something similar to this, where it's the same diagram, except I added this little wall here, so I can't just shoot it straight up and bounce it in like that. So it looks like I'm going to have to bounce it off of multiple walls here. And so it looks like I'm going to have to bounce it off of at least 2, maybe 3. Let's go with 3. Let's bounce it off of this wall here first. Let's call that wall number 1. And then let's do a second wall here. This wall up here. And then I know that this wall is the third wall. Let's bounce it off that wall. So again, I need to take the hole and work backwards, reflect it over each of the walls in the reverse order. So there's my h prime. I can find that pretty easly. And in this case, if you look at the numbers up above here, this is just going to be, like, for example, negative 2, positive 4, right? And then I can reflect it over the green. which puts it like way up here, right? Because the green is the line I'm reflecting it over. And then I can reflect it over the blue, which this is the blue line right here. And you're going to end up way over here. I can find each of those points pretty easily. Then I'm going to aim for the blue right here. I'm going to bounce off, and you have to just find this point right here that you're trying to find here. And you basically do the same thing. You know the value of the ball. You know the 2 coordinates for this hole that you've reflected twice. Actually, 3 times. Once, 2, twice, 3 times. And I know that the wall has an x value of 7, so I just plug in the x value of 7 once I find the equation of that blue line. And so that's what you do with something a little bit more complicated. Okay, sometimes we'll do this in Chapter 9. I may do this twice this year. I do want you to know how to simplify radicals throughout this book. So for example, square root of 24 here. Should have learned this last year, but you can simplify to the square root of, you want to find perfect square factors of 24. So 4 is, I think, the largest perfect square factor of 24. So it's square root of 4 times square root of 6 is the square equal to the square root of 24. Square root of 4 is just 2, or 2 root 6. 72, I can do, let's do 9 and 8 just for kicks. 3 times the square root of 8. Hopefully you can see that you're not quite done, because 8 has a perfect square factor of 4, so it's going to be 3 times the square root of 2 times the square root of 4, or square root of 4 is just 2, so it's 6 root 2. And if you could have seen at the beginning, you could have seen that 36 is actually the largest perfect square factor of 72. Some other things here. Let's take a look at this thing here. You can simplify. This is going to be what? It's going to be 3 root 2, right? Square root of 9 square root of 2. This would be 16 times 2, so it's going to be 4 root 2, and this will be 25 times 3, so it's going to be 5 root 3. Here's where you have to know something about radicals. Which one of these can I combine? It is going to be these two. Okay, think of it as like 3x plus 4x, and then this is 5y. So this ends up being 7 root 2 plus 5 root 3. So 3 root 2s plus 4 root 2s gives you 7 root 2s, and then you just add 5 root 3 to that. Let's see if there's any other concepts here. Oh, sure. Some on the back side here. Yeah, if I wanted to simplify like this guy right here, I can multiply, rationalize the denominator. Don't want any square roots in the denominator. Oddly enough, when you get to calculus, you're going to be rationalizing the numerator, but for now we're going to rationalize the denominator by multiplying by root 2 over root 2. I can multiply by root 2 over root 2 because that's just multiplying by 1. And so this is going to be equal to 28 root 2, multiply straight across, right, when you're multiplying fractions. And then root 2 times root 2 is just 2, right? Root 2 times root 2 equals 2. Root 4 times root 4 equals 4. Root smiley face times root smiley face equals smiley face. All right, so you get 5 times root 2 times root 2 is just 2, so 5 times 2. Hopefully you can see that the 28 and the 2 simplify to 14. So it simplifies to 14 root 2 over 5. And I do expect you to simplify radicals and rationalize denominators for the rest of the school year. Okay, if I ask for exact answers, that's what you're going to do. I'm going to leave the rest of these alone. You don't need to worry about like number 2 and number 3 especially. You'll be doing a lot of right at the beginning of next year in your algebra classes, algebra 2.